utilization of electrical energy. Okay, so in utilization of electrical energy, we have discussing electric traction too. Okay, so in this one you have to discussing the topic is analysis of simplified speed time curves. Okay, in this, so the speed time curves are simplified as trapezoidal and quadrilateral. In previous class we are discussing about the trapezoidal speed time curve. Now in this class we are discussing the quadrilateral analysis of quadrilateral speed time curve. Okay, see here, now we are going to analysis of quadrilateral speed time curve. See here, quadrilateral speed time curve for urban and suburban services for which distance between the stops is less. Okay, so here, so in previous morning, in previous class we are discussing the trapezoidal speed time curve. Okay, that trapezoidal speed curve is mostly used for the mainline services. So, and here the quadrilateral speed time curve. Okay, quadrilateral speed time curve is used for the urban and suburban services. Okay, so this is used for the urban and suburban services. Why? Because for which the distance between the stops is less. Okay, so here the assumption of for the simplified quadrilateral speed time curve is the initial acceleration and the coasting retardation periods are extended. Okay, so here initial acceleration state as well as the coasting periods and retardation periods are extended, and there is no free running period. Okay, in this so urban and suburban services means the distance between the stops is very less. Okay, so that's why at that time there will be a no free running period. So what is the meaning of free running period? In free running period, okay, the train travels along with constant distance, constant speed. But here there will be a no long distance between the stops, and here the distance between the stops is very less. Okay, so that's why here there is a no free running period, and here initial acceleration and a coasting period as well as retardation period both are extended. Okay, simplified quadrilateral speed time curves are as shown in figure. Okay, these are the simplified quadrilateral speed time curve. Okay, on x-axis we have to take the time. Okay, on y-axis we have to take the speed in kilometer per hour. Okay, here is a acceleration period, coasting period, retardation period. Here there is a no free running period. Okay, so here it is up to some particular distance it will be travels with a velocity speed v2, and after that whenever which goes to coasting period it will be reaches a maximum speed v1. Okay, so see here, let v1 be the speed at the end of accelerating period in kilometer per hour. See here, this is the v1. v1 is the speed at the end of accelerating. Okay, this total is acceleration period. At here, the coasting period will be starts. Okay, so that's why here v1 is the v1 is nothing but the v1 is the maximum speed in kilometer per hour at the end of accelerating period. Okay, so v2 be the speed at the end of coasting and coasting retardation period in kilometers. So v2 is at the end of coasting and retardation period. Okay, in kilometer per hour, and beta c be the coasting retardation. The retardation kilometer per hour. Okay, so time for acceleration. Okay, time for acceleration. So you have to take, so v1 acceleration v1 0. Okay, so that's why here you have to write t1 equal to v1 minus 0 by alpha, that is equal to v1 by alpha. The time per coasting period. Coasting is nothing but coasting. Up to now here you have to coasting. In between that speeds are v1 minus v2 by beta c. Okay, so that means the coating retardation you have to assume is beta c. Okay, that's why t2 equal to v2 minus v1 by beta. Last one, braking period, braking retardation. Time period for braking retardation. Okay, to come to the braking position, the time period will be taken as t3. Okay, to come to the braking retardation, the time period will be taken t3 equal to v2 minus 0 by beta. Okay, so that means this is v2. Okay, braking retardation, and finally the speed value will be 0. So at that time here you have to write t3 equal to v2 minus 0 by beta, that is finally is equal to V2 by beta. Okay, these are the T1, T2, T3 values. Okay, same as, so this analysis is also same as the trapezoidal speed time curve. So here also see the total distance traveled during the running period. Okay, whenever the train will be in running period, okay, so at that time the total distance traveled D equal to, so here also area under the triangle PQU as well as area under QURT and area under the RTS. Okay, see here the total distance traveled during the running period D equal to the area of triangle PQ plus the area of the rectangle UQRS plus the area of the triangle TRS. Same as trapezoidal speed time curve. Okay, see here the distance traveled during acceleration plus the distance traveled during the coasting retardation plus the distance traveled during the braking retardation. Okay, so that means here the distance traveled during the acceleration period as well as the distance traveled during the coasting period and as well as distance traveled due to the braking retardation. But the distance traveled during acceleration is equal to average speed into time for acceleration. So previous same trapezoidal speed time, here also we have to find out the distance traveled in individual cases. That means during acceleration, coasting period and braking period. And finally you have to add this R1 at the time the total distance traveled by the time you can get. See here, but the distance traveled during the acceleration equal to average speed into time for acceleration. So what is the average speed here? You can calculate previous one. Okay, so V1 by, see here 0. So average speed 0 plus V1. Okay, in acceleration period first the train starts with 0 speed and it will reach the maximum V1 into T1 kilometer per hour. Average, you have to take the average of these two. At that time you have to written as 0 plus V1 by 2 into T1 kilometer per hour per second. So here V1 by 2 into T1 by, so it is converted into the kilometers. So at that time you can get V1 by 2 into T1 by 3600 kilometers. Okay. The distance traveled during the coasting retardation. Coasting. In coasting, the time coasting it occupies the two speeds V1 and V2. So at that time you have to take average of these two speeds V1 plus V2 by 2 into T2 kilometer per hour per second. So at that time finally you can get V1 by, so these are also converted into kilometers. So at that time per hour it having 3600 seconds. So at that time here you have to write V1 plus V2 by 2 into T2 by 3600 kilometers. So similarly the distance traveled during the braking retardation. So in braking you have to assume the speed is V2 plus 0 by 2 into time for braking retardation. The time period will be taken for braking retardation is T3 kilometer per hour per second. So at that time here you have to write V2 by 2 into T3 by 3600 kilometers. Okay, finally you have to add these three speeds. Okay, that means these three the distance traveled, the total distance traveled by the train is get by distance traveled during acceleration, during coasting period and during retardation period. So at that time here you have to write D equal to V1 by 2 into T1. So this is the distance traveled during acceleration 3600. Okay, V1 plus V2 by 2 into T2 by 3600 plus V2 by 2 T3 3600. So in all you have to 7200. Okay, so in from all these so here also V1 T1 7200 V1, so it is splitted V1 7200 T2 plus V2 by 7200 T2. Okay, so plus V2 T3 by 7200. So from this all four terms you have to common V1 by 7200, V2 by 7200. So whenever you have to common V1 by 7200, V1 so by 7000 T1, similarly T2. Okay, T1 plus T2. Similarly we have to common V2 by 7200, here T2 and here T3. Okay, so next see here T1 plus T2. So what is the total time period taken by the train is capital T equal to T1 small t1 plus T2 plus T3. So at the time here you can write T1 plus T2 equal capital T of minus T3. Okay, so similarly T2 plus T3 you have to write capital T minus T1. So here also you have to write T minus T3. Here also T minus T1. So here also capital T and here also capital T. So whenever you have to common capital T by 7200, you have to write V1 plus V2 of T by 7200. Remaining terms of minus V1 T3 by 7200. Similarly, minus V2 T1 by 7200. Okay, so are you understood? Okay, so capital T equal to, that means the total time period taken by the train, capital T equal to T1 plus T2 plus T3. So from that formula, here you have to write T1 plus T3 equal to T minus of T3. Here also T2 plus T3 is T minus of T1. So from these two terms, you have to common V1, so capital T by 7200, here you have to write V1 plus V2. So minus V1 T3 by 7200 minus V2 T1 by 7200. Okay, V1 plus V2 of T by 7200 minus T3. What is the formula for T3? Previously you have to write V2 by beta. So at the time here you can write minus V1 V2 by 7200 beta. Similarly T1. What is the formula for T1? V1 by alpha. So at the time you have to write minus V1 V2 by 7200 alpha. Okay, so this is the formula. So from this one, so here you have to common from these two terms, here you have to common the V1 V2. Okay, so from this one you have to common minus V1 by V2 7200. So at that time it will become 1 by alpha plus 1 by beta. See here. So here you have T of 7200 V1 plus V2. Okay,